Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice exponential problem, and here we have 8 to the power of n plus 2 to the power of n is equals to 130, and we will solve this problem for the values of n or real values of n. So the very first thing we are going to do is here first I can rewrite this equation as, here you have 8 and we can find the prime factors of 8, which is 2 to the power of 3 and its whole power n, plus here you have 2 to the power of n is equals to 130. And in the next step I can use here the nice exponential formula, and you know about this formula. If we have a to the power of m to the power of n, it is equals to a to the power of n to the power of m, and it is whole equals to a to the power of m times of n. So this exponential law just tells us that if you can interchange these two exponents, then it cannot be affect the answer of this question. So here we just need to interchange these two exponents according to this law, so that here we get 2 to the power of n and its whole cubed, plus here you have 2 to the power of n is equals to 130. And now I can make the little bit substitution here in order to change this exponential equation into the cubic form, so that here I can just take y is equals to 2 to the power of n, and now I can put here 2 to the power of n is equals to y, so that it will becomes in the form of y cubed plus y is equals to 130. And now this equation will becomes in cubic form, and now we will solve this equation by making the factors of this equation. So that here we move first 130 in the left hand side, and you get y cubed plus y minus 130 is equals to 0. And now we can make the factors of this equation, so that here I can just break the middle term here, and here you can just write this plus y as minus, we can write this plus y as minus 25y plus 26y minus 130 is equals to 0. And now we can take the common y from the first two terms, and you get y squared minus 25, and we will take common 26 from the other two terms, and you will get here y minus 15 or y minus 5. When you can take common 26 here, then you get y minus 5, and this whole is equals to 0. And after this step we can use the formula here. First I can write this as y square minus 5 square, we can write 25 as 5 square, plus here you have 26 times of y minus 5, and this whole term is equals to 0. And now in the next step I can use here another square identity, and you know that if we have a squared minus b squared, it is equals to a minus b times of a plus b. So that we can use here this nice formula in the first term, and you get y times of y minus 5 into y plus 5, and here you have plus 26 times of y minus 5, and its whole is equals to 0. And now you can take common y minus 5 on both of the terms, and you get y minus 5 times of y into y plus 5 plus 26, and this whole is equals to 0. And now we will simplify the terms, and you get y minus 5 times of y squared plus 5y plus 26 is equals to 0. And now here we have two cases. The first case is we take y minus 5 is equal to 0, and the other case is we take y square plus 5y plus 26 is equals to 0. So in the first case you get the value of y is 5, and similarly we can find the real values in the second term in this quadratic equation. So that now first I can check this quadratic equation has real roots or not by applying the discriminant formula. So that here we have a is equal to 1, b is equal to 5, and c is equals to 26, and our discriminant formula is delta is equals to b squared minus 4 times of ac. And we can put all the values of a b c in here, and you get 5 squared minus 5 times 4 times of 1 into 26, and here you obtain 5 square is equals to 25 minus 4 times of 26 will be equals to 104. And when you can subtract 25 minus 104, then you will get minus 79. And here you see that our delta is less than 0, and if our delta is less than 0, this means that this quadratic equation has no real root. If it has no real roots, it means that it has complex roots, but in this question we need only real roots, so that we will rejected this case and we can proceed here this case only. And in this case we have y is equals to 5, and in the start of the question we will take y is equals to 2 to the power of n, so that we will back substitute the value of y, and you get 2 to the power of n is equals to 5. And now in order to find the value of n, we will take the log on both of the sides, and you get log of 2 to the power of n is equals to log 5. And now we can use the property of logarithm, and we can make or this exponent in the front of this log, and you get n times of log 2 is equals to log 5. And here you have n is equals to log 5 over log 2. And now you can use the calculator in order to find the values of log 5 and log 2, and the value of log 5 is 0.6989, and the value of log 2 is 0.3010. And when you can divide both of these two values, then finally you get the value of n is 2.3219. And this is the our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.